last time, if you remember, we were talking about the unit testing, integration testing, system testing, and how to split this all the way to acceptance test. So we've seen this already for the coding part. Remember, when we created a sample, we tried to see how to implement each of these test cases manually, and also how to generate it automatically with the JUnit tool. So it is the same idea here. Now we will move towards integration testing, where we simply combine and test as a group. Okay, so now it's more than one component at a time. We group them together and we try to test them for the sake of integration testing. So this is usually completely tested. We make sure we cover all possible test cases between these modules involved. And this phase is usually carried out by testers, which is not the case with unit testing. Remember, unit testing is carried out by developers. Remember? Okay, so now let's assume I have two modules in my application. Simple module that takes care of checking the current balance. Another one that helps me transfer an amount to another account. Let's assume this is my current balance, okay? And let's assume I want to transfer this amount. So after finishing this transaction, I need to end up with 500 in my balance and 500 transferred to the other account. So we discussed this scenario last time, if you remember. We said we have these 5 modules, and assuming that someone is done with his own job implementation-wise, while all others are still on hold. And we agreed we don't wait, right? So we need to find a way to make sure that this testing is done on time, even if other people are not fully done yet. So I cannot go here with the big bang approach. I can't say I'm waiting everyone to finish. This is simply time consuming, and it will be difficult for me to trace back the root cause of any bug, right? So when you test all together, you can't really tell who is bringing up this bug to place. But if you do it incremental, you can tell, okay, this bug is new for me, so this is coming mostly from this recent module I'm testing. So this brings up this logic that we already introduced earlier in the process, if you remember, in the process chapter. We were talking about the incremental testing. So how can I test my own application in incremental format? I have two approaches here, which we discussed already in implementation phase. We said we can implement top-down or bottom-up. But can I do the same also testing-wise? Yes. So let's assume, again, one component here is ready while it's not ready in the lower levels. You go for top-down approach. And let's assume here I'm done with these small modules, but the upper one is not done yet. Again, we go for bottom-up approach. Now you might ask and raise the question, how would I do it if I don't have the other component ready? Yeah? So the question here is answered simply with these two words. Here, if you're following a top-down approach, any missing item or any item that's incomplete, we do replace it with what we know as stop. And here, if any parent item or module is missing or incomplete, we replace it with what we call drivers. Okay? So just to give you the idea really quick, both act like fake dummy components, but they do the job, right? Remember when we said we synthesize data for the sake of testing really quick? That's the idea here. So let's look into this example. I have this interface. I call it balance service. Just like we know about interfaces, we don't implement them, right? So we provide here an abstract level of a method. This method accepts, let's say, an account node of type string. Okay. And here, because I don't have the actual information about my own accounts, I'm just gonna replace this with a stop. So let's assume the balance is the module that's incomplete in my code. So I'm just gonna create here balance service stop that implements balance service interface. And here I need to fully implement the get current balance, but again, this is not implemented for real, okay? So this is just a fixed value that we can use for testing. So this is my stub, okay? My stub is gonna return here value, which is 1000, okay? Now I can create two objects, one of type balance service, and using this stub, I can send it to the transfer service, which is another class, to double check with the value of that stub I'm creating. So now to show you the big picture, I have current balance, not implemented, so replaced by my stub, and my transfer module is fully and completely implemented. So here, if you look into the transfer, you do have a transfer method in it. This transfer method accepts here a value of an amount, and then it double checks if this amount is less than the value it receives from your stub. So get current balance was implemented where? This was implemented here, right? Which returns the fixed value 1000. So that's what I want to do here. Okay. Now the other idea is having driver class. So I have here balance service, and I do have the 1000 as well, but this time I'm expecting it to be my real data, okay? And let's assume also my transfer is complete. If I want to test these two modules together, part of integration testing, I need to create a main class, right? Now these are what we know as driver versus the real implementation. So this is my real class. This is going to be the driver I'm going to create really quick to make sure that these test cases are well addressed. So let's see what the driver actually have. So this is now the bottom-up approach, okay? So I do have here transfer of type transfer service. I do print my first test, which is going to send account 1, account 2, and the value of the amount. If you go back to the previous slide, you will see that we put here a constraint that the account you are sending to cannot be left empty, and its own length has to be 10. So if it's not 10, or if it's null, this is going to return false value. So here, part of my testing is double checking with various cases. My first case is when both accounts are valid. So 10, and then a value that's below my current balance, right? Which is 1000, if you remember. Second test case here is going to be two accounts, and I'm trying to send a value that exceeds my current balance. So this is 1500, while my current balance is 1000. Third case is going to be sending to an account that has total length 3, while I'm only accepting 10, sending any possible value that might be accepted. So now this is my driver. If we look into the actual implementation, then I'm expecting these inputs from the user side. You tell me what is the source account, you tell me what is the destination account, you tell me what's the amount. So this might generate hundreds of possible test cases, right? So up until this point is reached, we can still test our own applications. At least you make sure that your implemented unit is fully functioning and it does actually what's expected from it. Now we also want to double check, can we possibly test our own documentation? Yes. So if you remember, in the system modeling as a phase, we do generate lots of diagrams. Do you remember which one was this?
Sequence?
No.
Behavioral? No.
Structural.
No.
State diagram, exactly. State diagram. See, we have running, shutdown, testing, right? So these are different states. And these are nothing but transitions. Yeah? Remember this? Type. Now, knowing this from the previous phase, I can clearly tell that I need this mostly to be reflected in my class diagram or object diagram. So I can tell all these methods that I have as part of my transition leading to the change of the state from one to another need to be implemented and part of my class implementation. So this is how you verify diagrams and sketches. And this is something also needed by the system testing level. So you want to make sure that all these diagrams, including sequence diagrams, if this is, let's say, one scenario, requesting a report, and then you double check how the system responds back, returning this report to the user, you need to find a way to possibly test these data, right? So a summary report can still be tested by creating raw data instead of depending on the full implementation that sends realistic ones. But again, we are testing here the ability of the system to create a report and send it back, right? Regardless of what data are pushed in or out. So the focus of system testing is mostly on the interaction between components. We check here that components are compatible, they interact correctly, and they transfer the right data in the right time across all interfaces. The sequence diagram associated with the use cases documents the components and the interaction that are being tested. So again, we do the testing for use case diagram, sequence diagram, state model, and all of this. Okay, now we do look into user testing. User testing is a whole phase that we also discussed in the VB model, if you remember. But it does start here with 3 different stages. We call it alpha testing, beta testing, gamma testing. Do you know what's the last layer?
User testing.
Huh?
Acceptance testing.
Acceptance test. Thank you, Wajd. Yes, acceptance test. Wajd, right?
Yeah.
Okay. طيب, so what's alpha testing? Now, this is a stage of testing that's done on the spot or the site of the developer. So whoever handles it, it's the team, development team. And this is happening internally, okay? We do simply fix bugs related to our own code. But when it comes to beta testing, we do test it mostly with selected user group. Just like some applications, if you open Play Store, WhatsApp is one, you might find yourself among the beta testers. So you get to see the new features even before they are publicly available. Ever happened?
Yeah. Yes.
Nice, perfect, yes.
So is this done by random or is it accessible to everyone?
It depends. It depends on the publisher and developers. You might select a specific group of people and tell them, okay, please give it a try. Like many people do testing even for the prototype level. So they sketch, let's say, with Figma, and they publish through Figma, just a simple prototype. And the community of people dealing with Figma are the beta testers. So it depends, again, on the website, depends on the developer preferences. You can do it internal with a group of people who might be using your application, and so on.
What if it's something like WhatsApp? Would it be accessible to everyone? Or?
Most likely you select a group of people. Could be in a specific country. Because some features are introduced, let's say, in US before and introduced in KSA, or the opposite. So you might choose group of people because you're comparing it to millions, right? So your group of people might be 100K people, okay? So again, it depends on how big the system is and the users are. Now, the gamma testing phase is what focuses on stability. We don't go here down deep into the coding anymore. We just want to make sure that if 100 users actually try to get access to this service at a time, it will still function well, okay? So here I'm just checking that the system can be still stable at various level of variables, like the overload, the bandwidth, the networking issues, all are fixed. And I do have the last layer here, the acceptance test, that can tell me that the system is ready to go. And again, who verified this one?
The acceptance?
Yeah.
It's about users.
Stakeholders, exactly. So it's telling them exactly if it maps to my own requirements or my own expectations or not. Now, in between these two levels, there is release, okay? So I go for alpha, beta, gamma, release, then acceptance test. Now the release is itself split in 3 levels. pre-release, release, and post-release. What happens before is we create a plan document. We say this is go or no go. And here we simply create tags, deploy code, deploy server, and then we test inside the release. And then here we prepare a rollback plan. What happens if a change happened, if something is not expectedly phased? Now, I do have also the acceptance test, as we said. It goes for the functional level of requirements. And here you simply go for bug hunting in real life user experience, right? In general, I do have types of testing. So we can split this in black box, white box, gray box. This intermediate level is what we covered already: unit, integration, system, user acceptance. Then we have all of this list. I'll discuss it briefly. You need to know this one mostly. So when I say I'm doing a black box testing with my own application or my own code, it means I'm testing functionality without knowing how the internal code is actually made. So if I'm using system.out.println, I don't need to know how println is made, right? But I'm using it. This is black box. If I'm using white box, it means you are the implementer. You have full details of the internal logic, how the code passes and structure is made, right? And if this is gray, it means it's in between. So you're using it, you're not the one who made it, but you know exactly how it's made, right? Now these are very interesting ones. I recommend you get through it. I left for you here down a brief list of description. For example, you can check the monkey testing, let's say, when you input random values to test the application performance differently. You can do, let's say, GUI testing, which is something you will need actually in 220, where you check buttons, menus, screens, everything that works actually perfectly, and so on. Of course, usability testing is quite common. You have agile testing, again, it's the process. What else? Compatibility testing to make sure you can work on different devices, operating systems, and so on. So I just recommend you give this a quick try. Last thing I want to show you here is the difference between test plans and test cases. So test plan is usually the big document behind, and you can fill it with hundreds of test cases, right? As we've seen, you can even categorize these test cases differently. That's a sample from ISO standards, a template that can help you through the testing plan, where you simply go across a checklist telling you which of these documents are actually made. So for example, design document, do you have this document ready or not? Is it created? Is it revised? Is it approved? Is it changed? And so on. You can just keep track of this. Prototype, is it ready or not? User manual, is it ready or not? Data model, is it ready or not? And so on. So you just test the completeness of these documentations to make sure you're adhering to the right process and cycle. Then you can go into testing stages. So you can go here for unit test, integration test, system test, acceptance test, and each will have a table similar to this one, which includes the objective of this test, techniques used, like automated, let's say, or manually made, completion criteria. So I might accept 2 defects in my system. That might be of low priority. Or I might need to not let go if it had a single defect, right? Responsibility on developers. Sometimes you cannot outsource, let's say, to test an application, because this might be a critical system. Could be military-based, right? So the information that are describing how the system works cannot actually be revealed to public. So here you declare if there is any responsibility as developers or testers. And if there is any special considerations, you also list it. So that's one tool actually that helps you automate the process and share it among a team. You can create a test plan. You can add to it test cases as needed. Every test plan could have a name. You can list under which multiple test cases connect even a team member or a group of people to it. And you can have a full dashboard displaying for you all possible test cases and the status of each of them, like which one is complete, which one is still on hold or whatever. All right, that's simply it for our course. I'll end it here. I want to thank you for the hard work. I know it's been a long semester for everyone, but it was nice meeting all of you. I will end it here. I'm full ears if you want to share any comment, concern. I would love to hear your feedback about the course and possibly how to improve it later.
Do we tell you we're done?
Yeah, we're done.
Thank you.
We're done, we're done. If you need more, I can give you more, so I don't feel like you can.
Thank you.
Thank you. That's a pleasure. It was a pleasure meeting you all. Again, literally like one of the very special patches. I don't think I'll forget you easily.
That's actually you mean that, right? Like that's an actual comment, right?
What?
Like you mean that.
I do mean it. I do mean it. I never say anything that I don't mean. No worries. I'm fully transparent. It shows on my face.
Will you teach us any future courses?
In 1.5 years, inshallah. Inshallah. But at that time, you will be third-year students. Very, very nice meeting you at this early stage of your software life cycle, and we're here. So I wish the course was useful to you. Again, if you feel like there is any point where we can improve the course, I'm willing actually to give this a try. All in all, I hope this was a good introduction for you to what's coming. The course is pretty easy, but I know that sometimes with the stress and the long list of due dates and whatever, you might actually feel stressed. I hope it was a nice experience for you, but again, please share with me any concern you have. Is all good?
Yeah.
Is that silence okay? All right. Thank you so much. So here is the deal before you leave. For next week, we will start utilizing the class time here, 201, for the 220 course. So we just finished for you easy, like faster as well. But for 201 ladies, you don't have to worry about this.